Advanced Higher Chemists, this one is for you. Let's go over this equilibrium question in the 2014 Advanced Higher paper where we're asked to calculate an equilibrium constant. To start off, you need to have answered A part 1 and have the expression for the equilibrium constant K. For the equilibrium expression, just remember it's always the concentration of the products over the concentration of the reactants, and it has to be raised to the power of the number of moles of that substance in the balanced equation. Also, don't forget to ignore anything that has an L or an S state symbol. They don't get included in the equilibrium expression. So now we have our expression for the equilibrium constant, we can go on to use the experimental data to calculate it. My favourite thing to do when I am doing calculations is to write the numbers given in the question above the chemicals in the reaction. So we're told we have 0.7 moles of sulfur trioxide, so I've written that above there. It's in a 1 litre container, which we don't really need to use. And then it tells us that at equilibrium, the mixture was 0.125 moles of oxygen. Now, to be able to work out the equilibrium constant, we need to know how much of everything we have at equilibrium. So we know how much oxygen we have at equilibrium, but we don't know how much of the other things we have yet. To work out the amount of the other product, we just need to use simple stoichiometric ratios. So if we've got 0.125 moles of oxygen, then we must have double the amount of sulfur dioxide because it's a 2:1 or 1:2 ratio. That means at equilibrium we'll have 0.25 moles of sulfur dioxide. Now, to work out how much of the reactant is at equilibrium, we need to do a subtraction. So because it's also 2 moles in the ratio, that means we must have used 0.25 moles of it. So we just have to take what we had initially away from what we would have used, and that gives us what's left at equilibrium, which in this case would be 0.45 moles. Now we have all the quantities of the reactants at equilibrium, we can just plug them into our expression equation. That then gives us this, and if we put that all into our calculator, we should get 0.0386. Just as a bonus, because this equilibrium constant value is below 1, that means that we have more reactant at equilibrium than we do product, which means the equilibrium will sit to the left of the reaction.